Hello everyone. We're looking at powers of whole numbers next. So in these notes, we're also looking in the book. And so powers just means that we're repeating multiplication. So here we have 2 to the power of 3. We'll call 2 the base, 3 the power, or the exponent, fancier name. And it's written like this, so yeah, just to emphasize. So 2 goes here, and then the slightly smaller 3, but make sure you move it up. Anyway, that means just 2 times 2 times 2, so you're multiplying 3 2's together. Okay, so 2 times 2 is 4, times 2 is 8. And so just, so some different things you can do with 2 and 3. So 2 plus 3 is 5, 2 times 3 is 6, and 2 to the power 3 equals 8. So we're just making sure we know the basics. Let's look at some different powers. So any number to the power 1, well, that's just the same number. You're not doing any multiplication, you just have one of that number. So yeah, so we usually don't write first powers. But then, yeah, a confusing one is if you have a number to the power 0, that's defined to be 1. Okay, so every number to the power 0, just remember that's 1, except for if the base is 0, then 0 to the power 0 is undefined. Okay, so any number to the power 1, you get the same number. So 13 to the power 1 is 13, but 13 to the power 0 is 1. Yeah, this rule makes more sense when we talk about negative exponents, but that's not this course. 1 to the power 0 is 1. 0 to the power 1 is 0. Okay, 2 to the power 1 is 2. So yeah, so these are the simple rules. Anything to the power 1 is the same number. Anything except 0, anything except 0 to the power 0 is 1. So those are the easiest powers. The next power is 2. Okay, so any number to the power 2, that just means you want to multiply the number by itself. So n to the power 2 is just n times n. 3 to the power 2, that's 3 times 3, that's 9. And you can usually say that as squaring. Okay, so 3 squared equals 9. So squaring just means raised to the power 2. Where's the square? Well, yeah, so here's the square. If you have a square that's 3 units by 3 units, say 3 feet by 3 feet, then the area of that square is going to be 9 square feet. Alright, so that's where the squaring comes in. A third power, that's often called a cube. So cubing, and that's just this was 2-dimensional, so that's just a 3-dimensional version. So if you have a cube that's 3 feet by 3 feet by 3 feet, then its volume is 3 to the power of 3, 3 cubed, which is 27 cubic feet. Okay, so yes, remember those Rubik's cubes? So if you break up a Rubik's cube, you're going to find 27 of these guys inside. Okay, so just cubing means third power. Okay, here we have 15 squared as an example. So here the base is 15, that's a bigger number. So we're squaring, so it's just 15 times 15. So like we were doing last time, multiplying numbers, so doing this by hand. Just more practice. So starting with this 5, so 5 times 5 is 25. Write down the 5, carry 2. 5 times 2 is 1. 5 times 1 is 5, plus the 2 is 7. And then multiply by the 1 in the tens place. So 1 times 5 is 5. So it has to go here. Starting in the tens, and 1 times 1 is 1. Add those two numbers, we get 225. So 15 squared is equal to 225. Okay, so squaring, cubing, what about a fourth power or higher? Yeah, they don't have special names. We can only go up to the third dimension here. But so yeah, this is 5 to the power of 4, so if you're asked to work that out, well, it's 5 times 5 times 5 times 5. So we're just working left to right. So first we have to figure out 5 times 5, well, that's just 25. Multiply by that by another 5, we need 25 times 5. Okay, that's 125. And one more 5, so 125 times 5, multiply that out, that's 625. Okay, so just to check, yes, so we have multiplied 4 5s together. 5, 25, 125, 625. And so that's the answer, 625. Okay, so you can see higher powers, that's going to be more work. Although there are some bases that are easy to take powers of. So here we have 0. So if the base is 0, so 0 to the power 20, for example. So what happens if you multiply 20 zeros together? Yeah, not much. Anything times 0 is 0. We saw that last time. So any power of 0 is just 0. Easy. Similar with 1, so any power of 1 is just 1. Yeah, so these are the only two numbers with that property. Tens, yeah, if the base is 10, then it's also an easy case. You don't have to do any work. So every time you multiply by 10, you just add a 0. So 10 to the power 9, you just get this big number, and it's got 9 zeros. Yeah, how do you say this number? So it's 1,000 millions. So this is 1 billion. Okay, if it was 10 to the power 20, then it would just be a 1 followed by 20 zeros. Okay, let's take a look in the book. Did we cover everything here? So yeah, so more powers, 3 to the power of 4, 2 to the power of 5. Here, 4 to the power of 3. Yeah, so 3 to the power of 4 is 81. 4 to the power of 3 is 64. So it makes a difference if you switch the base and the power. Yeah, we saw this rule. So any number to the power of 0 is 1, except for 0 to the power of 0. And squaring, cubing higher powers. Yeah, so just getting used to squaring. You could fill out this table. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 9, 16, 25. So those numbers are called the perfect squares, 36, 49, 64. All right, let's look at square roots next. So yeah, this is a kind of a trickier concept. Causes problems. Okay, we looked at squaring. Well, square roots are the opposite of that. We also have a special notation for the square root. That's this radical symbol. It looks a bit like a long division symbol, but that's different. So don't get confused. So make sure you put that little mark there. Okay, so we have a radical. So the idea is, yeah, I like this diagram. So if you start with the number 3 and square it, you get 9. So 3 squared is 9, 3 times 3. For square roots, you're going backwards. So the square root of 9 is 3. Okay, so square roots are asking, so what number squared gives you that number? Here it's 3. So in our using our radical notation, so the square root of 9 is equal to 3. And if you want a reason, it's because 3 squared equals 9. Okay, so squaring goes this way, square roots goes back. So another example, so if we're looking for this square root, we want the square root of 25. So the question you should be asking is, which number squared gives me 25? Well, you could do some trial and error if you weren't, if you didn't know the answer. So you could say, well, maybe the answer is 4. 4 squared is 16. That doesn't work. But try 5. 5 squared is 25. So that works. So the square root of 25 is 5. How about this one, the square root of 100? Well, the answer is 10 because 10 squared equals 100. All right, so the square root of 100 is 10. That seems clear, but I just see this so often. The square root of 100 equals 50. Can't we just divide by 2? No, so don't do that. Okay, so square roots are, it's not the same as dividing by 2. Yeah, it's kind of easy to do if you're you're trying to work fast, but just remember it's connected with squaring, not multiplying by 2. Some more examples. It's kind of confusing ones. So here, the square root of 0. So we're asking what number squared gives you 0? Well, yeah, if you think about it, if you square 0, you get 0. So 0 is its own square root. Same for 1. The square root of 1 is 1. Here we're asking what number squared gives you 2? Well, the answer is not 1. The answer is not 2. 2 squared is 4. We see that here. So in fact, yeah, there's no whole number that works. In fact, yeah, you can see that the answer is between 1 and 2. The square root of 1 is 1. The square root of 4 is 2. So the square root of 2 and the square root of 3, you can write them as decimals. We'll see that later. So as a decimal, the square root of 2, I think it's like 1.4 ... The square root of 3, it's like 1.6. So all we're saying for now is that it's square root of 2. It's not a whole number, but it's some number between 1 and 2. And the same for the square root of 3. Okay, so those perfect squares I mentioned before, 1, 4, 9, 16, 25. So those are the only numbers that have nice whole number square roots. Yeah, here's another one. The square root of 16. What number squared gives you 16? 4 is the answer. Again, not 8. 4. The square root of 16 is 4. Yeah, we'll take a quick look in the book. But yeah, just again to mention some other common mistakes. Yeah, that lots of mistakes to make in this with square roots. So one mistake I see a lot is something like the square root of 16 is equal to the square root of 4. No, so we saw it up here. So once you've taken the square root, then you don't need the radical symbol anymore. So the square root of 16, it's just 4. It's not the square root of 4. So no. Again, the same issue here. Yeah, once you've worked out the square root of 9, it's just 3. It's not the square root of 3. And here, I've gone in the wrong direction. Yeah, so the square root of 9, it's 3. Here I've squared instead of taking a square root. Okay, so the moral is, yeah, just do any square root questions carefully. So yeah, in the book, yeah, so these square roots we're talking about are the principal square roots, the positive square roots. We'll talk about negative square roots later. So yeah, you can think about this using our areas of squares idea, kind of going backwards. And so if you want a square of area 4, then its side length has to be the square root of 4. 2 times 2 is 4. If you want a square of area 5, well, what's the square root of 5? Well, it's some number. It's going to be between 2 and 3. It's some number 2 point something, so that when you multiply it by itself, you get 5. So not a whole number. An example here, between what two consecutive whole numbers does the square root of 53 lie? Well, if you notice that 49 is a perfect square, the square root of 49 is 7, the square root of 64 is 8. So since 53 is between 49 and 64, and then the square root of 53, it's some number between 7 and 8. So 7 point something something. Okay, so you can estimate square roots even if they're not whole numbers. An example here, what's the square root of 169? So if we're doing this by hand, then yeah, the only way to do it is really to kind of trial and error. So you could say, well, is the answer maybe 10? Well, 10 squared is 100, so 10's too small. How about 12? 12 squared is 144, still too small. But if you try 13, then 13 times 13 is 169. So the square root of 169 is 13. All right, so yeah, these are easy on the calculator. You can check your answers on the calculator, but we're trying to do these by hand again for now. Okay, next, division. Let's go back to the notes. Okay, division of whole numbers. So yeah, we've looked at addition, subtraction, multiplication, powers. Yeah, so the last operation is division, maybe the trickiest operation. We'll spend a lot of time in this course looking at different ways of looking at division. So here, let's start with 12 divided by 4. Okay, so what does division mean? Yeah, so always think about, what this really means. It really means how many times does 4 fit into 12? And you can see it fits in 3 times. Okay, so 12 divided by 4 is equal to 3. It's sort of the same information as here. 4 times 3 is equal to 12. Okay, so division and multiplication, they're opposite or inverse operations similar to addition and subtraction. How about 13 divided by 4? Okay, so you can see that it's not going to work out as nicely. So how many times does 4 fit into 13? Well, it still fits in 3 times, but now there's 1 left over. Okay, so 13 divided by 4 is equal to 3, with the remainder of 1. Okay, here's the multiplication version of that statement. 4 times 3 plus 1 is equal to 13. Another example, how about 34 divided by 5? So we're asking how many times does 5 fit into 34? You can try multiply some 5s together. Yeah, you can see it fits in 6 times. 5 times 7 is 35. That's too big, but 5 times 6 is 30. And you can see there's 4 left over. Okay, so 34 divided by 5. One way to write the answer is that's equal to 6, remainder 4. Yeah, we have some jargon here. So that's 6. That's called the quotient. So the quotient is how many times does it fit. The remainder is what's left over. The remainder was 4 here. Also, the number you're dividing by is called the divisor. There's a name for this, the number that gets divided. That's also called a dividend. All right, so the remainder, it can be 0. Okay, so that's the case when it divides in evenly. So 12 divided by 4 was 3, with no remainder, remainder 0. What's the biggest the remainder can be? Well, the biggest it can be is 1 less than the number you're dividing by. If your remainder is bigger or equal to the divisor, then that means that the divisor fits in more times, so you made a mistake. For example here, what's 30 divided by 7? Well, you could say 7 fits into 30 3 times, with 9 left over. But that's not correct. That's not the best you can do. See, this remainder 9 is too big. It's bigger than 7. So that means you can fit in one more 7. So in fact, 7 fits into 30 4 times, with remainder 2. Okay, so now the remainder is less than 7, so now it's correct. Yeah, here we saw we were dividing by 5 and the remainder was 4, so that this 4 is the maximum possible remainder when you divide by 5. Okay, so I hope that's making sense. So just remember, for division, it's all about fitting in. How many times does the divisor fit? Okay, for bigger numbers, we can use long division. So let's look at this example. Find the quotient and remainder for the division 159 divided by 6. Okay, so we put the 159 here and the 6 here. No. So that's not correct. So yeah, we just remember the order of the numbers gets switched. So the divisor goes on the outside. Yeah, this is our long division notation. Yeah, it looks a bit like a radical, but it's different. Okay, so here's 159 divided by 6. So the 6 goes on the outside. And just like our other questions, like when we're multiplying, it's very important to keep this neat. So yeah, so don't write these digits too close together. So first we start with this 1. So how many times does 6 fit into 1? It doesn't fit. So we could write a 0 here, but so let's look at 15 instead. So how many times does 6 fit into 15? So it fits twice. And since we're talking about 15, I'm going to put the 2 here above the 5. Okay, so not over the 1. It's 6 into 15 goes twice, so put the 2 above the 5. Yeah, like I did here. Next step, well, 2 times 6 is 12, and subtract that 12 from the 15. Okay, so it's like we're getting what's left over. That's going to be 3. Okay, so those steps are making sense. So 6 fits into 15 twice, and 2 times 6 is 12. Subtract that 12, we have 3 left over, and then bring down the 9, so we'll get 39. Okay, so now we're looking how many times 6 fits into 39. So you can see it fits in 6 times. So 6 fits into 39. 6 times, that's 6 goes above this 9. 6 times 6 is 36. Subtract, we get remainder 3. All right, so that's now we can write the answer. So this number up here, this is the quotient, and this number here is the remainder. Just double checking that, yeah, 3 is less than 6, so it's a good remainder. If we got, say, a 13 or something, then we'd have made a mistake. So 159 divided by 6 is equal to 26. So 6 fits in 26 times, and there's 3 left over. That's the remainder. And yeah, we're writing it like this, a quotient, and then capital R to signify the remainder. Yeah, later on we'll look at decimals, so there are other ways to write this answer. You can write this answer as a decimal, but we're just stopping. Okay, so we stop as soon as we get all the digits. So we started putting that 2 over the 5, then we had to fill in the next digit. What was the digit we needed over the 9? So as soon as we filled that guy in and got a remainder, then we're stopping. So yeah, in the book, similar. Some more examples here. This is just emphasizing the connection between multiplication and division. So 63 divided by 7 equals 9. That's a division statement. The same information in terms of multiplication is 9 times 7 is 63. And more long division. Yeah, here, this example, the divisor is a bigger number. So here it's 23. Doesn't fit into 1. It doesn't fit into 10 either. So right away it's 23 into 100. So you could multiply some, figure out some multiples of 23. So 23 times 3 is 69. 23 times 4 is 92. So that's the best you can do. It's 23 into 100, so the 4 goes here above this 0. 4 times 23 is 92. Subtract that from 100. We get 8. And that's the remainder. So the quotient is 4, the remainder is 8. example. Yeah, here's a trickier example. Yeah, you have to be a bit careful with zeros. Okay, so let's see. So here we have 3060 divided by 15. Okay, so some bigger numbers. So we'll use long division. So 15 doesn't fit into 3, but 15 into 30 goes twice. So put the 2 over this 0. 2 times 15 is 30. And subtract that 30. Now you get 0. Okay, next, bring down this 6. Okay, now we're looking at 15 into 6. So how many times does 15 go into 6? 0 times. Okay, so we have to put a 0 over the 6. All right, it's clearer here. Yeah, 15 goes into 6 0 times. Yeah, so we need that 0. Next, bring down this last digit, this 0. You can see there's still a space above that 0 we need to fill. So bring down that 0. Here it is. Now it's 15 into 60. And that goes 4 times. Four times 15 is 60. Subtract, we get 0. Okay, so the answer is 204. So the quotient is 204. The remainder is 0. So 15 divides evenly into 3060. It fits in 204 times. Nothing left over. Okay, so yeah, the moral is, just do these long division questions slowly, sort of step by step. Make sure you don't miss any zeros in the quotient. And yeah, keep everything lined up properly. And one last quick section, division and 0. So I'm making the same points here. You just have to be a bit careful when 0 is involved in any division question. The point is, you can divide by any number except for 1, 0. Okay, so what happens if you try it? I talked about this in the introduction. So for example, if you're trying to work out 3 divided by 0, well, in terms of fitting, we're asking how many times does 0 fit into 3? Well, since 0 doesn't take up any space, you can keep fitting it in as many times as you like. So really the answer here is infinity. But infinity is not a number, so we say 3 divided by 0 is undefined. So this is the correct answer. This is the only correct answer. You have to say 3 divided by 0 is undefined. If I switch the two numbers though, how about 0 divided by 3, just to try and confuse you? This does make sense. And so how many times does 3 fit into 0? It doesn't fit at all, or it fits in 0 times. Okay, so you can think about these in terms of fitting numbers fitting into the second number fitting into the first number. But we always have this situation. So any number divided by 0, that's always undefined. Another way to say that is you're not allowed to divide by 0. But if 0 comes first, that's okay. So 0 divided by any number, well, any number except 0, 0 divided by any non-zero number is always 0. That's just saying you can't fit anything into 0. All right, so that's powers, square roots, and division. So I've added homework number 1 to the class page, so take a look at that based on this chapter 1 material.